Subject is terminals. If anybody was here, they just saw a really wonderful. Oh, now I sound much louder now all of a sudden.
Just like we.
Okay, well, if people were here in this room earlier, they saw a really wonderful, well put together professional presentation by Bill Hurd. This is not that kind of presentation. So I've been asked to speak about terminals. It's also obviously a very huge subject. Who here is like familiar, or is unfamiliar with using terminals? Has never used one? Never hooked one up to anything? Okay, everybody's familiar with terminals, so half the talk is redundant. So then what? People on the video might not. People on the video? People watching. Oh, okay. Well, both of those people that are going to watch this video might want to know something about terminals. But anyway, okay, terminals, as we all know, are serial interface devices for the most part. There's a lot of different categories of them. There's the very early things like teletypes, and then you start getting into glass terminals. You get into IBM terminals are weird. They're their own special thing. They talk over either AS400 stuff is uses Twinax, which is a round connector with 2 pins, or the 3278 type terminals use a terminal node controller, and they connect over BNC. I'm not talking about those weird types right now. I'm just talking about regular, normal serial terminals. This is kind of the quintessential serial terminal. This is the DEC VT100. It came out in the late 70s. This is not the first terminal by far. This is just one of the most popular, most common types of terminal that you're likely to encounter. A lot of things are VT100 clones. A lot of things are backward compatible with VT100. And in fact, the terminal window in your modern Linux distributions is all VT100, VT102 compatible. It's the same sort of escape codes. As a simple demonstration, I have this terminal. It's just displaying the cursor. I don't know if you can see it. And I've got it connected via the usual nightmare of serial cables and a USB adapter to my Chromebook. And then on the Chromebook, I've got a piece of software called BeagleTerm, which is a terminal emulator. And this is doing the same thing. It's pretending to be a VT100 terminal. It's doing the same thing. I've got it connected to this terminal. And if I connect this, now anything I type on the Chromebook should show up on the VT100, and it doesn't. It did a minute ago. Oh, it is. Oh, I forgot to click in the window. Okay, so everything that I type here is being sent to the terminal, and everything I type here is showing up on the Chromebook. And the way this is attached is obviously through RS-232, the serial, regular serial. The port on the back of the terminal is wired as what is called DTE. So there's 2 different types of wiring for serial devices. There's DTE and DCE. DTE is anything that's a terminal, data terminal equipment, DTE. A terminal, a computer, something like that is all wired as DTE. Modems were wired as DCE, data communication equipment, meaning you can connect with a straight-through cable from device to device, have the terminal connect to the modem without anything weird. But of course, this is a computer, and this interface box is DTE wired. This is meant to connect to, or this is a computer. So in order to connect these two, I need what's called a modem eliminator or a null modem, which is an adapter that switches the serial wires over. And what I mean by that, here's a pinout of the connector on the back of the terminal. And you can see that pins 2 and 2 here is pin 2, or pin 2 is transmit data, pin 3 is receive data. So the terminal outputs on pin 2, it's transmit, and then the computer after it converts to 25, also transmits on pin 2. So they can't talk to each other. The wires need to be switched. So the adapter crosses over, receive and transmit, and then the various other RS-232 control lines get crossed over as well. This little adapter box here, this is a light box. It's called a Christmas tree tester. It's just a visual indication of what the various lines on the serial line are doing. And when I connect this, if I connect it the right way around, you can see that, okay, transmit, if I disconnect it, I only have transmit, because the terminal's transmit is doing something, but it's not connected to anything. If I connect this, then I have receive from the computer, and then the DSR and DCD, these are control lines I'm not going to bother getting into right now. The basic connection you need to connect a terminal to something is just 3 wires: receive, transmit, and ground. Yep, 2, 3, and 7, exactly. That is the simplest possible serial cable you can make, and it will generally work in almost all circumstances. The only problem you might run into is things called flow control. So the serial data is being sent by the computer, but the terminal can only process it so fast, the computer can only process it so fast, so they can kind of start to overrun. So then there's 2 methods of flow control. There's hardware flow control, which actually uses these extra control lines to say, hey, to stop the transmission of data, resume the transmission of data, or it's done inline with control characters. So is there anything anybody's curious about with terminals? Any questions about terminals in general? I mean, I'm going to babble forever if I don't have some direction here.
I guess I was just pointing out, if you're doing anything with like terminals or serial devices and you're trying to hook them together, get the set of the Christmas tree devices. Every penny and the amount of time and frustration to save you is a lot.
Yeah, this will show you immediately if something's doing something. He was just pointing out that getting one of these testers. If you're doing anything with serial, anything with terminals, anything with connecting disparate objects together through serial, you want one of these testers. They're pretty cheap. I think something like that. If that, I think I paid $7 for this. They're really easy to make too, if you want to. Another question?
I'd also recommend if you're doing that, a breakout box.
The breakout box is definitely helpful. I have one. I didn't need it for this setup, but a breakout box would just take the 25-pin connector, break it out to pins that you can easily connect with jumper wires, so you can see what's going on. Very handy device to have. Exactly. I was going to say, I've lost my train of thought again.
Real quick, classically, with a lot of stuff with Commodores or run-of-the-mill terminal, what baud rate are you usually operating at?
Well, it depends on what you're to connect to. The traditional, like standard.
Remember to repeat the question.
Oh, sorry. Yeah, I have to repeat the question. He's asking what baud rate to operate at. First, I should mention what baud rate is: the speed that the computer devices are transmitting or receiving. The traditional baud rate of something like a teletype machine is 110 baud. And that's your standard, like the lowest common denominator, 110 baud. Modems, 110 or 300 for the very early stuff. When you start getting into more modern systems like PDP-11s and whatnot, pretty common to run at 1200, but 9600 baud for a direct attached device is pretty standard. It stayed standard for a very long time. So even things like Cisco routers, Sun servers that have a console port, that's what those ports are for. Those RJ45 is just a serial port. There is the console port on certain devices is just a serial port. You can adapt it and connect AVT100 to your Sun Netra T5100 or whatever, and get to the firmware that way. Yes.
One thing you might want to mention for any young kids watching at home, you have to set that at both ends. It doesn't negotiate.
Oh, of course, yes. No, so I guess one thing I should mention with terminals is that they're all very, very different, right? I mean, a terminal in its basic form is just a keyboard, a monitor, the electronics to do all of that. In fact, this one, I'll take the cover off. There's not a whole lot in here. Yeah, it's a black and white monitor. There's the high voltage and the electronics back here, and then you've got one board of logic. This one is microprocessor controlled. I think it's an Intel 8080 in this one. Some were Z80 controlled. What?
I think it's an 8085, but
It might be. Yeah, I don't remember. Some terminals, like the one on Jason's shirt back there, is like the ADM3. Have no microprocessor whatsoever. It's all TTL logic. There's a 40-pin UART. There's a bunch of basic logic to run through, just handling the screen, and that's it. There's no processor. And so you hear people talk about a dumb terminal versus a smart terminal. The lines start to get blurred. Something like an ADM3A is a dumb terminal. It's very simple. It can do basic cursor position. It has no microprocessor. Can't run any kind of local code. This is microprocessor based. You could consider it a smart terminal because it can do some advanced features. It can do, you can have it display, split the screen and display text from in different parts of the screen at the same time. It can do lots of features, but it still can't run any local code. It's just a terminal. It just sends and receives data. Configuring a terminal, they change depending on, every company made their own type of terminal. They did it their own way. So you have something like an ADM3A, which you set with switches. This has a setup menu, so you can go into the setup menu, and then you have to hit setup, toggle it over the things, and here's where you set the transmit and receive speed. This one you can actually set transmit and receive to different speeds. I don't know why you would ever want to do that.
There were modems that worked 1200 up to you and like 75 or 150 back.
Yeah, I've never seen a system running like that. That makes sense. So if you're doing credit card processing on a VT100, there you go.
It also makes sense that you might get a burst of data from the computer that you're talking to, but the fastest the data going up is going to be as fast as you can type.
Yeah, so it wouldn't be as noticeable, yes. But yes, you have to set the speed on both ends. You also have to set the parity and the stop bits, and that's what I clicked through it quickly on the terminal emulator here. If I bring this back up.
The old hardware were 7-bit, not 8-bit.
Correct.
IBM PCs, you think 8-bit, but a lot of them were 7-bit and a parity bit.
Yeah, a lot of PDP-11s were 7E1. And so there's, I should mention what that means in case people don't know that. So you have each data byte is either, you've got the ASCII characters being sent by the terminal. So if I hit A, it sends the ASCII character for A through the serial port to the computer here. And it would have is that ASCII character represented by just the 7 bits or the full 8 bits? Parity bit, there's an error correction bit at the end, whether you have it or not. No parity is pretty common, but again, some of the DEC stuff used even parity. Some other things used odd parity. Then a stop bit. You can either have 1 bit or 2 bits. 1 bit is common. So you're kind of the what? This is already a complicated enough subject.
If you're getting garbage on the screen, it's more than likely a misconfiguration.
Correct, yes.
Of the number of bits in the character, because it's trying to decide where the character
Or the baud,
stops.
or sometimes the baud rate. If you have the baud rate wrong, you'll hit one character and you get a whole bunch of stuff all at once, or vice versa. The computer's sending you what you're expecting to get 1 line of text and you get 10 because the speed is wrong.
At least on this one, it's programmable. You're not having to screw around with dip switches.
Yeah, this one is programmable. It's a nice and easy, modern type of interface. The VT220 is even easier because on this one, to set all the options, there's these basically virtual dip switches you have to turn on and off manually, and there's a chart printed on the bottom of some of the keyboards, not this one.
They would all of them and they disappear over the years.
Yeah. When I was grabbing keyboards, I should have gotten one with a chart stuck on the bottom of it. But every terminal is a little bit different, and every terminal's protocol is a little bit different. The standard, the VT100 protocol is compatible with a lot of stuff, but then you start dealing with a Weiss terminal or some of the other brands. Then you start getting televideo. Televideo is weird because you have to set the attributes. So the terminal can only do text, but it can do other things with the text. Some of them can do bold text. Some of them can do underlined text. Some of them can do blinking text. But there's no bit in the ASCII character set for blinking, right? There's no 8-bit code for a blinking letter A or a letter A that's in bold. So what you have to do is you have to turn those features on and off as you're sending the text. So it's a control character, a control sequence, something that uses a combination of the control key and something else. Sometimes it's an escape sequence. Some kind of code that is in that data stream you're sending to the terminal but isn't part of the text. So you'd turn on the bold feature, kind of like HTML tags, right? You'd turn it on and turn it off. You'd have the bold text surrounded by these character that turns on the bold, then turns off the bold. Televideo does that differently than DEC does. So if you connect a DEC terminal to a machine that's expecting a televideo, you're going to get, the text is going to be right, but there's going to be anything that does special, anything bold, anything that positions the cursor is going to be wrong.
If you're working in a number of OSs, Unix and Linux, for example, they have termcap and terminal.
Yeah, I'm getting to that. I'm trying to.
They have definitions that says if the terminal is this and you want to do this, send this character set thing.
Exactly. That was in my list of things to get to, but yes, if you're connecting it to a Unix machine of some kind, there's going to be a terminal type definition database, either termcap or terminfo, depending on modern distributions of Linux tend to use terminfo. And there's a great website I should tell you about. No, it's the CatB Terminfo termcap resource page. This is the Bible when it comes to terminal information. This has everything, every terminal type definition for every terminal you can think of, a whole bunch you can't think of, and probably a bunch of terminals that don't exist anywhere anymore. I mean, I've been collecting terminals for years. I have lots and lots of different brands and makes and models. I've got some really obscure stuff. Almost everything is represented here. I'm not going to get into this because especially more of Linux at this point or Unix. But if you're doing anything with Unix, you can download the correct terminal type definition. You can compile it using like terminfo tick, terminfo compiler. You can put it in your system and let your computer talk to the terminal correctly. Because of all the different types of protocols these things handle, if you try to run more complicated programs like even VI is pretty simple, but Nano, like it displays the text at the bottom of the screen. If you run it on the wrong terminal type, it'll get all screwed up. And some terminals are kind of primitive, like they can't do all the fancy things a VT100 can do, and that's kind of what Unix is designed to use, is a VT100. So programs like Nano that do all that stuff, you try to run that on an ADM3A that doesn't have a lot of those features, it gets kind of crippled.
A lot of the Linux stuff was hard-coded for ANSI/VT100.
So, yeah.
ANSI and VT100 are not the same thing?
They're close, but they're not the same thing. One of the most common areas you run into problems with is the backspace character. Or what character do you use for the backspace? So this is connected, and if I type, that would explain it. Where's setup end? Right, yeah, and it's really easy to do this. Oh, you just turn it on and off, yeah. Yeah, I'll just turn it on and off again. Okay, so now we should be connected. Okay, so you can see what I'm typing. But if I hit backspace, notice nothing happens. Because this is sending the ANSI backspace sequence, but the terminal is expecting Control H. So if I hit Control H, the cursor goes backwards. But if I actually hit backspace, this is sending, I think, the escape, the ANSI delete program. Yeah, it's yeah, I can never remember. I look it up.
I can't quite see from here, and I can't remember. Is that a destructive backspace, or is it just moving the cursor back?
That is just moving the cursor back. That is not a destructive backspace. So and then you've got, you see, when you get to the end of the, okay, what does enter do? Is it control, does enter bring the cursor, like this is doing just enter, or return. So this returns the character to the middle, or the cursor to the beginning of the line. Line feed is a separate key on this terminal. It's right here. Which is sending it to this, not there. The other thing is I could put the terminal in local mode, and then anything I type on the terminal would show up. That's the other thing, is because I've just got two terminals connected to each other with no software whatsoever, the terminal isn't echoing what I type. And there's no handshaking going on. They're not echoing what each other is showing. The computer, a normal computer interface would do that. It would handle all that in software. Yeah, I think you're right. Let's see.
Yeah, Control M, Control
Yeah.
Control M for return, Control J for line feed.
Yep. But when you start dealing with different types of terminals, they all have their own little escape language thing, and that's what the termcap terminfo database handles, is that sort of thing. There are some terminals I've encountered that are really, really weird. I have an old Interdata terminal from the 1970s, that is a rebadged tech, TEC, not TEK, and it uses, it's an uppercase only terminal, and all the control codes are uppercase letters. So when you connect it to a Linux box and it displays the prompt, it's sending it in mixed case. And all the uppercase letters are making the terminal go nuts because it's moving the cursor all over the screen. You know, because the terminal doesn't know. The only way to tell the terminal what to do is to send it a code. So in order to move the cursor somewhere else on the screen, you have to position it and then tell it, you know, where am I moving the cursor to, display some text. There's no feedback loop. The computer can't know where the cursor is on the terminal. It just has to count and remember. So whenever it starts, with that particular terminal, it was weird because anytime you said anything uppercase, it just would do strange stuff. It would move the cursor around. It would beep. It would do stupid things. So there are some really incompatible terminals. For instance, there is no entry for that. I tried writing a termcap file for that terminal. Almost impossible because Linux is not meant to work that way.
Part of the problem is they took lowercase only support
out of Getty.
Out of the Getty.
Yeah,
They stripped the support from the OS.
I recompiled it and made that work. I got it to work. I did get it to work with modifying Getty and using STTY flag to parse it. It still didn't work very well because then, you know, it's not meant to send uppercase characters as control sequences. So you run into a lot of really weird stuff with a terminal. And there's so many, that's why I enjoy collecting them so much, is because there are so many different types, different interfaces, different ideas as to what makes a good terminal. Ultimately, the VT100 kind of won. Everything you see today is VT100 compatible. Xterm is VT100. VT102 compatible, has the extended stuff for the colors and everything. And the standard's certainly been extended far enough. But then, they are interesting devices. Does anybody else have any questions about terminals in general, history of terminals?
If you want to test VT100 compatibility, there's a C program that works on, can be compiled on almost anything called VT test.
Yep, VT test.
It will verify to the bug level how close your VT100 emulation is.
It does some of the VT52 stuff as well, too, like the double width characters that.
VT100 supports both in switch settings, sets it to 52 mode.
Yeah.
So it has to support that fully as well.
Mm-hmm.
But you can use that to find out a large number of the VT100 equivalent programs are no longer VT100 equivalent. They've been so modified to where they lose it.
Right.
You could get Procom Plus working in the old days. You could get Telex work fairly well. Kermit is the gold standard for the emulation.
Yep.
In freeware. But a lot of the things that claim their VT100 capabilities, including the terminals that were included in Windows, failed miserably.
And I don't doubt it.
They will work in things like Linux and VI, but that's as far as the testing worked. They never tried to run it against a real piece of DEC hardware. They don't cut it.
I believe it. And for the most part, a lot of the terminal emulators will work close enough. One of the worst terminal emulators I've ever used is the Lisa terminal. As Jason laughs, it is terrible. It can barely go above 1200 baud. Graphical terminals, yes, there are graphical terminals. The Tektronix graphics is kind of the most common, where you have like something like the 4010, Tektronix 4010. It uses a storage vector tube, and that's a really interesting beast. And maybe I should have brought one of those as a demo. That'd be more interesting than something everybody has already seen or has. Yes. Yeah, that's a good one. He's just asking about the history and the engineering mindset as they evolved. The very first computers were, you have lights and switches, and you've got very simple ways of getting data in and out of the computer, but that's kind of inefficient. You'd like to be able to just tell it what to do and have it tell you something back. The very earliest things that we would consider terminals would be more like a teletype machine, where it's a mechanical printer and a keyboard. Everything you type on the keyboard gets serialized and sent to the computer. Everything from the computer gets deserialized and interpreted and printed out on paper. This is at the time was cheap and effective and worked pretty well, but then you can't do anything like editing files becomes really kind of a pain in the neck because, okay, you want to go back and edit line 52, but you can't just scroll up. You have to tell the editor, oh, I want to work with line 52, and now you have to either retype the line or make substitutions based on it, because you can't move a cursor around a screen. You're very limited with a printing terminal. The printing terminal started out with like the teletypes, the Freedom Flexor Writer, and then started to get to more modern like dot matrix type printing, like the Deck Writer printing terminals, LA36, the LA120. It was a dot matrix printer attached to a keyboard, worked the same way with the same limitations. But being able to see things on a screen and edit them. I mean, I think IBM might have been one of the first to do that, where they had, I forget the model number, but it was a very complicated, very expensive system, but it proved that the concept could work. One of the limitations with terminal design, and it was always been, you need an awful lot of memory for the time to remember the character position of all these letters and store all that information. There's like, I think 2 kilobytes of RAM in a lot of terminals just for the screen. Usually it's static memory. Some of the really early tech I was talking about earlier, that uses shift registers. There's a board about that big full of metal can shift registers that just sits there recycling the data around and around because RAM wasn't really an option. Some really early terminals, like some of the Hazeltine terminals, used core memory to store that information. There was little bitty core planes in there.
How late did that continue? 1500 have core?
No, the 1500 did not. The 2000 did, or early 2000s did. Late 2000s used static memory.
And if you turned the Hazeltine off and came back the next day and turned it on, your screen was still there.
Yes, because core didn't lose its stuff. So the memory was always a real limitation. One of the things preventing, like, you think, oh, we'll just put a video display on the computer and have a keyboard right on it, but that's really inefficient. The computer needs all that memory, it needs to be able to talk to it. The terminal was the cost-effective option, especially because now you can share the computer. You have one computer and a dozen terminals. Everybody has their own little terminal on their desk, and the computer can share.
One of the things this deck was famous for is they had an add-in board that let you double the amount of memory. And when you added the add-in board, you could get 132 characters on all 24 lines instead of 13.
Correct, because
13 was a limited factor by the amount of memory in the terminal.
right, and that was the AVO, the advanced video option. This particular terminal doesn't have it fitted. You'll see, so there's a VT100, which is the base model, does not have the advanced video option, but you could add it. Then there's the VT101, which is a cost-reduced VT100 without the AVO, and you couldn't add it. You couldn't upgrade it. And then there was the VT102, which was the cost-reduced VT100 with the AVO built in already. But screen memory was a real problem. And if we start to talk about doing graphics, these days you'd think, oh, you have a 640 pixel by 480 pixel screen. Oh, that's, it's, I don't know, mega RAM, 256K of RAM, that's nothing. But back then, it was a huge deal. The computer might not have that much memory.
It was looked upon as how many boards worth of RAM you can try and jam in a terminal. It's like
Right, but
the size of the RAM was, they were, 2K static, 4K static.
right, but what I was trying to get at was that a way around that is to have the tube store the data instead of having the electronics. So the way Tektronix did it was they used a storage tube, like in their oscilloscopes, that could actually store the phosphor. It would remember where the phosphors had been lit up without the electronics having to constantly refresh it like a regular CRT. So you could draw these wireframe drawings in a 1024 by 1024 pixel map, which was ridiculous for the 70s. And by only storing those points where the corners of everything were and where to draw the lines about it,
To keep refreshing the lines.
but you didn't have to refresh the lines.
They only lasted as long as the phosphor, which wasn't that long. That's not true.
It would last until you cleared it.
The ones I saw,
They stay lit forever. The laser or the beam, sorry.
Yeah, no,
Charge on the
please
laser.
correctly.
yeah, there's a separate plate. There's a separate plate in the face of the tube that stores that, and it will store it for. I've never actually sat there and timed it, but certainly an hour.
It's not storing on that.
Yeah, if it's fading, there's something wrong with the terminal. It's supposed to be able to store it nearly forever.
Maybe that was the way the software was set on that for some specific.
Maybe,
He
but
was doing circuit board design, maybe they didn't want it to store longer than a certain amount of time
so
as he was moving the lines.
one of the tricks with so the problem with the Tektronix terminal was that everything stored, but the problem was that everything stored You know, you couldn't just erase some of the text and have it kind of, you have to redraw the whole screen all at once. So in order to do that, you have to either manually redraw it or set a command, an escape sequence from the computer to refresh the screen. It would flash bright green and redraw. But if you wanted something like the cursor, you don't want the cursor to store because it's going to be everywhere. So the cursor was really low intensity. It was just very light. And that could have been what, maybe they were drawing the lines in the low intensity mode where it intentionally wouldn't store, because there wasn't a really good way to, other than making it low intensity.
They would design a circuit board that was doing the layout of the board, so it may have not been using cursor.
Yeah. But that was another type of terminal. It was a serial interface back to the computer, and that was in the 1970s they were able to do that. And they were able to get a 1024 by 1024 pixel graphic display without having the ridiculous amount of memory you'd need to do a 1024 by 1024 pixel graphic display.
That used to have a 14 and a 17-inch CRT with light pen.
Okay, yeah.
VR17, VT.
Yep, sounds about right.
11. That's stuff they drew the lunar lander game on originally, where you'd try and land a LEM on the moon. It had a wireframe of a LEM, and you'd control by certain toggles the amount of energy being put there to slow it down so it didn't hit the moon and
Right, yeah.
or crash.
That, I think,
That was originally done before PC stuff ever came out. It was originally done on PDP-11.
yep. I think that was, I'm trying to figure the VR17, I think that was a graphic display that was directly driven by the computer, though. I don't think it was technically a terminal. I don't remember. I've never actually,
It was driven by a 3-board set in the computer.
Right, so it wouldn't really, I mean, it is kind of a terminal, but it's not technically so there's other things you'll encounter. There's a thing called, Vector made a device they called the mindless terminal. It looked like a terminal, it smelled like a terminal, but if you opened it up, there was no terminal. It was just a keyboard and a monitor in one plastic casing, and then both of them were connected externally to the computer, and then the computer had the video interface in it. Wang did that too. Some of the Wang terminals for like the 2200 was the same kind of setup. But yeah, I think we had that working at one point. But anyway, that's neither. But is there any other terminal related? Yes.
How easy are there any gotchas in connecting these to, say, SIM-H running on
That's been done many times. In fact, my friend DJ can help you with that. He's done that more recently than I have. But you need a similar. This is a RS-232 to USB adapter. These come in many shapes and forms, and they're cheap these days. You'd need something like this. You could plug it in. There's also Raspberry Pi has a GPIO serial on it, but then you need to do the level shifters. That's the other thing. Is RS-232 is not TTL level. It's like plus or minus 15 volts or something like that, and you need transceiver chips. Yeah, you need Yeah, you need special transceiver chips, the 1488 and 1489 pair to drive that. If you ever encounter a terminal that doesn't want to talk to anything, so okay, one thing I should talk about real quick is how to test a terminal. If you, I don't have a paperclip with me, but if you short pins 2 and 3 together on the connector, I'll show you bring the pin out again. If you just take a paperclip and join pins 2 and 3, or in this case, this has a female connector on it, so I can do this with a screwdriver. And now, did the text show up? Yep. Now if I remove the screwdriver, it doesn't. And because I've looped the thing back, I've connected its own transmit back to its receive. That is a quick and dirty way to test a terminal. That's what I'm saying. So it tests the entire path. So local mode in a terminal doesn't always do that. Local mode links it back in software sometimes. Some terminals actually does link it back after the transceivers. But by looping it back that way, you can verify that the transceivers both work. And if that's not working, then there's something wrong. One of those transceiver chips is blown, which is pretty common from static. Yes?
There are a few that are in between. The TI Silent 700 is one of them. You can't do that trick on. You've got to do data carrier detector. It won't do anything.
IBM 3151 does similar kinds of things. It really wants something with the... Yeah, you'd have to loop multiple things. Yeah. You're right, there are terminals like that, but they're very few and far between. There aren't very, almost all terminals can be at least configured to work with no flow control and ignore everything, yeah. And the other thing is, like, serial lines can run quite a long distance. I forget, I'm sure somebody probably knows the exact spec, but something like that, a long distance. You can certainly run it anywhere in your house pretty easily. That's another advantage of a serial terminal versus, a monitor and a keyboard. You could have the computer in this great big room with raised flooring and have the terminal someplace where it isn't so loud. Yeah. Yeah, you can definitely run at that distance. For even longer distances, they would use current loop. And current loop is what a teletype uses. It's the same sort of signal as RS-232, but it's different voltage levels, and it uses, instead of voltage pulses, it's current pulses. But you can convert between the two. They would also run higher voltage, yes. And that would higher voltage over current loop lets you run a lot longer distance. Almost as if you wanted to build a system of telephones. Any other? Let's see, how am I doing on using up time here? Oh, okay, perfect.
Different tech altogether. Any advice on refurbishing the cases?
Oh, like this one's all yellowed. That's not really my specialty. I've dabbled in retro bright. Some people have had fantastic successes. Others have turned a terminal into this weird bleachy, splotchy mess. I don't like to get involved with that too much. For the retrobyte?
Getting the cases to look pretty decent.
I mean, I just clean them with some spray cleaner, and I found this stuff called Mean Green at Walmart. That's a really great cleaner. That and paper towels can get most of the crud off. But as far as de-yellowing, I don't really do anything with that. This one, I should have cleaned this one a little bit better, but it works. Repair-wise, I'm not going to get really into that this time, but terminals tend to be broken. It's always the things, the interfaces, the keyboards stop working because the key switches get gunky or the key tops get busted off, and the monitors die. Power supplies are also a problem. This is a DEC terminal, so I'm kind of surprised that the power supply still works correctly.
The 100s were pretty solid.
This is
on that common is the video board going.
right, and I'll cover how to repair those in my CRT repair class. But this is an older one, so this is the power supply on this one's a little bit more reliable. Some of the later ones I've had issues with. And these terminals have I think a 24 volt or something, 27, some weird voltage. So the other thing is configuration settings. Some terminals use a battery to store that information. Some terminals use dip switches. This one uses a chip called an EA-ROM, electrically alterable read-only memory. And it's like a predecessor to an EEPROM. It's the same kind of chip that the game like Dig Dug used to store the high scores, but it needs a high voltage to set those settings. So it's something like 24 volt. I forget. I could look it up. Yes.
I guess speaking about keyboards, can you talk about, like, you can't just use any keyboard.
Yes, that's a good point. In fact, if I would have made I was going to talk about that, and if I would have been organized and made notes for myself, that would have been on it. Keyboards. This keyboard is compatible with this terminal. It's compatible with nothing else. That is pretty much the standard across the board with most terminals. The keyboard needs to be for that terminal from that manufacturer. Is it the 5-minute warning or? Yes. Oh, okay, perfect. The terminal needs to be from that from that manufacturer. The keyboard needs to be the correct type. Some keyboards are intercompatible, like the keyboard between the VT220 and the VT420 are compatible. It's the same protocol. Some manufacturers kept the same protocol for several models. Others churned out tons of terminals with tons of identical-looking keyboards with the same plug. They were not compatible, like IBM or Weiss.
There's clones of this made by Televideo that look a lot like, but if you plug the Televideo
You're thinking CITO. Televideo made the 950, which looks very similar, but the keyboards are different. They're phone connector versus this.
CITO, I know if you plug that into a VT100 or that VT100, that you get smoke.
Yeah, the CITO. So CITO made a clone of the VT100. It looks identical, except it says CITO. The keyboard looks almost identical, and the plug is the same, but they don't work. So you got to be really careful. Make sure that the keyboard you have for a terminal actually works for that terminal. Yes.
Here's a question that won't help anybody else. VT100 and VT105.
Okay.
Do you know if they use the same keyboard?
Yes. Yes, they do. The VT100, the VT. Yeah,
They're the same terminal with an added board.
Yes, the VT100, the VT101, 102, 105, 125, VT180, they're all the same terminal, based on the same chassis. So yeah, they use the same keyboard. Okay, yeah, key switches are becoming a failure point. This type of keyboard uses these little spring contacts. You can't see, obviously, because you're too far away, but it's these little fingers on one side and a flat thing on the other with a bar in the middle and a spring, and whenever you press the switch down, those close. The switches, the contacts are exposed. You can see them right here from the top. So if the keys get lost, which happens, these, especially the setup key, this is one of the few VT100 keyboards that have with a setup key still on it, because it always gets broken off right at the top. The contacts get mangled or they get dirt down in them. So these can be cleaned. You have somebody to clean these. Fixing these keyboards is a pain in the neck because you can't just replace individual switches easily. Other types of keyboards, like on the Weiss terminals, tend to use standard little micro switch circuit board mount. They clip into a little frame. Standard little switches that you can scavenge off some other keyboard to fix it, or I think they still make those. The little plus-shaped actuator on the top. Actually, keyboards have become a bit of a problem with terminal collecting in general because people have decided that they like destroying the keyboards for other purposes, so it makes it really hard to get the keyboards for the terminals. So make sure that you if you find terminal keyboards, yeah.
There are capacitive foam.
Yes, capacitive foam keyboards are Cume used capacitive foam keyboards, as did some other brands, and that type of contact, it's a foam disc on the bottom of the key switch, and the circuit board has some pads on it. It's capacitive, and when you press the foam disc down, there's a piece of mylar on there. The problem is all the foam deteriorates, turns into gunk, turns into dust. And Jason Perkins can tell you all about that because the Lisa keyboard uses that, as does the Sol 20, the TRS-80 Model 2, the Compact Portable, Cume terminals, some of the ADS Viewpoint terminals use those. You find those capacitive foam keyboards everywhere, and they're all dead now. So if you get a terminal where none of the keys work, check to see if it's that foam kind. Usually those will, when you take a key off, there'll be a spring underneath the key, and that'll kind of clue you in. You can also take the circuit board out and flip it over. You'll see no contacts for the switch contacts. You see the circuit board is screwed to the frame with a whole bunch of screws, but there's no like wire leads coming through.
So lots of novices see those intertwined traces on the keyboard and assume that, oh, I can just short it to see if it works.
No, so one way, if you have a capacitive foam keyboard, you're not sure what's going on, you can take it apart and you can touch with your fingers. You can type on it with your fingers because the capacitance of your fingers will work on those those pads, but don't short it out with a screwdriver because you could damage the keyboard controller. Okay, I am at the very end of this. Is there any last questions? Yes. VT240 was separate. Uses a separate monitor. It's a graphic version of a VT220. It can do some basic graphics. Uses the same keyboard as the VT220. The monitor. So okay, the VT240, the monitor on that is a VR201. It looks special. It's not that special. It's a composite monitor with a pass-through for the keyboard. So if you ever get a VT240, what? The 240, yeah, it's the same terminal base, it's just a different monitor. Because the VT240 can generate the color, you just need the color monitor, and that's a little bit hard to find. It's a 15 kilohertz RGB monitor with sync on green, so you can rig it up to other things if you don't have the correct monitor. Same thing with the DEC Rainbow, which isn't a terminal, it's a computer, but you can also, again, you can rig up a regular monitor to that.
And the same keyboards work across those DEC PCs?
Correct, yep, it's the same keyboard. If you ever have a choice between an LK201 and an LK401, get the 401. The LK201 keyboards are heat staked together and the membranes fail. So when one breaks, there's really not a good way to fix it short of breaking all those heat sinks, taking the whole thing apart, fixing the membrane, sticking it back together with, I don't know, screws or something. It'd be a nightmare. The 401, however, is held together with plastic snaps. You can take the whole keyboard apart and clean it. Even if somebody spilled a Coke in it 20 years ago, you can fix it.
Another thing on those keyboards specifically, certain keyboards in that set are collectible rare. The ones with the gold keys and the word processing keys are in demand.
Why? It's the same keyboard.
Deckmates use that and are dedicated to use those dedicated keys. And if you don't have them on the keycaps, you can't use the machine worth a damn. Because of the keycaps.
I guess. I mean, but those keyboards.
Don't pay $60 or $100 for the keyboard.
Right. Yeah. The standard one
The
is.
rest of the terminal is yours for nothing if you can spend a little.
Anyway, I think we're out of time. I'm sorry I babbled. I'm glad you liked me standing here babbling about terminals for a while. If anybody has any questions about terminals, fixing terminals, collecting terminals, or has terminals they don't want, let me know.